Welcome to a webcast produced by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Algebra series and concerns factorising quadratic expressions. This guide introduces quadratic expressions and gives a simple technique to aid in their factorisation. Quadratic expressions are very common in mathematics, and it is useful if you can identify them and then factorise them. For example, being able to factorise a quadratic expression is extremely useful when solving quadratic equations. Factorisation of quadratic equations leads to their roots, and there are many methods to find these roots. However, factorisation is the simplest and quickest, and it is beneficial to practice this skill. Here you will concentrate on the technique of factorisation by inspection, or factorisation by eye. What is a quadratic expression? Technically, a quadratic expression is a polynomial expression of order 2. But what does this mean? Every quadratic expression fits the pattern ax squared plus bx plus c, where a, b and c are numbers, called coefficients, and x is a variable. The coefficient a can take any positive or negative value except for 0. b and c can take any value at all. You can see that a quadratic expression has a highest power of x of 2, which is why it is of order 2. It may, but not necessarily, contain two other terms, one dependent on x and a constant c at the end. The term quadratic comes from the Latin word for square, quadratus. Let's do some examples. Which of these expressions are quadratic in nature? A. 3x squared plus 4x minus 5. This is a quadratic expression with a equals 3, b equals 4 and c equals minus 5. B. Minus x squared minus a quarter. This is also a quadratic expression with a equals minus 1, b equals 0 and c equals minus a quarter. C. 5 minus 3x plus x squared. This is also a quadratic expression with a equals 1, b equals minus 3 and c equals 5. The term order is unimportant. D. X plus 4. This is not a quadratic expression as there is no x squared term. This is a linear expression. E. X to the minus 2 plus x squared. This is not a quadratic expression due to the x to the minus 2 term. F. X cubed plus x squared minus 2x minus 9. This is not a quadratic due to the x cubed term. G. 4x squared minus 3x. This is a quadratic expression with a equals 4, b equals minus 3 and c equals 0. Factorising quadratic expressions. Before you learn how to factorise certain quadratic expressions, it is important not to forget to account for any common factors that may be part of the expression. These need to be factored out before you begin the analysis outlined below. Your first thought should always be, are there any common factors? If so, you can factorise them out using the method of simple factorisation. See study guide, Simple Factorisation. You will concentrate on quadratic expressions without any common factors here. Factorisation introduces brackets into an expression or equation, and in order to set up the technique, let's expand the brackets x plus m times x plus n, where m and n are numbers. X plus m times x plus n equals x squared plus mx plus nx plus mn, which equals x squared plus m plus n all times x plus mn, where the two middle terms have been factorised themselves. If you find this difficult, see the study guide Opening Brackets. Can you see the expanded form is a quadratic expression? Specifically, If the number multiplied by x squared is 1, the number multiplied by x is m plus n, and the constant is m multiplied by n. Thinking of this process in reverse offers a strategy to factorise quadratic expressions which fit this specific pattern. Let's do an example. Factorise x squared plus 3x plus 2. This quadratic expression fits the pattern of x squared plus m plus n times x plus m times n, where m multiplied by n is equal to plus 2, and m plus n is equal to plus 3. You need to find the answer to the question, which two numbers are multiplied together to give 2 and added together to make 3. Can you see that the numbers must be 1 and 2, as 1 times 2 is 2 and 1 add 2 is 3. These are m and n. Substituting these results into x plus m times x plus n gives x squared plus 3x plus 2 equals x plus 1 times x plus 2, which can be easily checked by opening the brackets. The technique of factorisation by eye is precisely this: asking the question, which two numbers do I need to multiply together to give, in this case 2, and then add together to give, in this case 3. Let's do another example. Factorise x squared minus x minus 12. This is more difficult. Which two numbers multiply together to give minus 12 and add together to give minus 1? If you cannot deduce them, you need another strategy. Create a table to help you. Draw a table with two columns. In the left-hand column, list all the whole numbers which multiply to give minus 12. A good way of creating this list is to start with 1, then 2, then 3, and so on. Once you have a complete list, in the right-hand column, add the numbers. If one of the sums is equal to the number you require, then you have found the two numbers. The table below is for the question above. In the left-hand column, we list the numbers that are multiplied to make 12. And in the right-hand column, these numbers are added together. Plus 1 times minus 12 is minus 12. And plus 1 add minus 12 is minus 11. Plus 2 times minus 6 is minus 12. And plus 2 add minus 6 is minus 4. Plus 3 times minus 4 is minus 12. And plus 3 plus minus 4 is minus 1. Plus 4 times minus 3 is minus 12. And plus 4 add minus 3 is 1. Plus 6 times minus 2 is minus 12. And plus 6 add minus 2 is 4. And finally, plus 12 times minus 1 is minus 12. And plus 12 plus minus 1 is 11. In this case, can you see that the numbers needed are plus 3 and minus 4? They are circled to help you. So, x squared minus x minus 12 equals x plus 3 times x minus 4. Importantly, the table above gives every possible whole number for m plus n when m multiplied by n equals minus 12, specifically minus 11, minus 4, minus 1, 1, 4, and 11. This allows you to easily see whether a quadratic expression can be factorised using this method or not. So, x squared minus 2x minus 12 cannot be factorised by this method, as minus 2 does not appear in the right-hand list above. Take care when the numbers you need are of different signs. Make sure that you assign the correct sign for each number. Example: factorise x squared minus 9x plus 14. On first inspection, this seems impossible, as you have 1 times 14 and 2 times 7 giving 14, but neither 1 plus 14 nor 2 plus 7 equals minus 9. However, something that is often forgotten is that two negative numbers multiply to give a positive number, so you also have minus 1 times minus 14 and minus 2 times minus 7 giving 14. As minus 2 add minus 7 equals minus 9, then x squared minus 9x plus 14 equals x minus 2 multiplied by x minus 7. The difference of two squares. A special case of a quadratic expression is the difference of two squares. The general quadratic expression for the difference of two squares is x squared minus m squared and can be factorised to give x squared minus m squared equals x plus m times x minus m. Importantly, the left-hand side contains a subtraction, not an addition. Identifying the quadratic expression x squared minus m squared allows the factorised form to be written down immediately. Of course, if you don't realise you have the difference of two squares, the previous method still applies where the addition of the two numbers is equal to 0. Example: factorise x squared minus 36. Notice that 36 is a square number, 6 squared, so you have the difference of two squares. Using the formula above with m equals 6, you find x squared minus 36, which is x squared minus 6 squared, is equal to x plus 6 times x minus 6. Even knew that. Further guidance and information. If you have any further questions about algebra or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor, or make an appointment to see a learning enhancement tutor in the Dean of Students office. You can telephone 01603 592761, email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students office at the University of East Anglia.